question 7. So start off by working out each to one significant figure. So 600, 3 and 10. 3 tens are 30. 600 over 30 is the same as 60 over 3, which is 20. Number 8. Start off by working out each to one significant figure. 6, 300. Now be careful, this is not 1, it is 0.5. 1 is just far too inaccurate. 1 is almost double 0.523. This has to be 0.5, but you're still following the rule of one figure which is not a naught. Then normal maths, 6 lots of 300 is 1800, but be careful, how many halves fit into 1800? That's 3600, or in other words, what's 1800 times 2? 3600. Question 9. So, starts off okay, I think, part A. So, upper and lower bound, well, little r is to one decimal place. So, the biggest it could be is 1.75, the smallest is 1.65. Big R to 3 sig figs, the biggest it could be is 31.5, the smallest it could be is 30.5. Now part B is a bit strange really, it's a lot easier than it looks. Find the smallest possible value of big R take away little r. So if that's going to be as small as possible, you want big R to be as small as possible, but little r to be as big as possible. So 30.5 take away 1.75, which is 28.75. Now for part C, we're talking about these spheres being melted down and used to do other things. So this is a question of volume. So we want to work out the smallest possible number of spheres that could be made when you melt down the big one and create small ones. Now the smallest number possible will be if the biggest one to start with is as small as possible, yet what you're creating is as big as possible. So we're going to need to work out the smallest the largest sphere could be and the largest that the smaller sphere could be. So the smallest the largest sphere could be, we're going to be using our 30.5, so the smaller bound for the larger sphere. So substituting that into the volume of a sphere formula, here, straight out of the front of the paper, we get this. And then moving on to the largest that the smaller sphere could be, so using the upper bound for the smaller sphere, the 1.75, we get this. So this is the volume of the largest sphere, the smallest sphere, the smallest the largest sphere could be. This is the largest that the smaller sphere could be. How many would that generate? Well, it's going to be 1 divided by 2, which is 5505.6. So how many would we actually generate of completed spheres? Don't round up, round down. So 5505 spheres.